All right, I think we'll get started here. Bill Schwan will join us in a moment. This is Matt Schwegler with ITC. Thanks for joining us for today's live tutorial on the basics of SUAS and aerial infrared. And I think we'll get right into it. I'll just pass the control over to you, make you the presenter. I'm going to mute my camera for right now, but you should now have control. And I'll take any questions. Like we have a question break coming up about slide 25 or so, and then we'll take more at the end. But anytime you're ready, you can go ahead and share your application there, and we'll roll right into the main presentation.
Good morning, Matt. Hey, good morning. Can everyone hear me okay, I hope? But here we go. Hey, we have, I just want to thank everyone for joining us today for the basics of unmanned aerial systems and thermal imaging. We have well over 250 attendees joining us today, so that's pretty exciting for me. Well, let's get started here. And I want to thank Matt Schwegler, too, for helping us put this together in making sure everything goes smooth as far as getting the webinar and the information out to you. So let's get started. In this today's tutorial, we'll introduce you to SUAS systems and some applications. This is not a training or certification webinar. There's simply not enough time to cover all the materials in the quick 45 minutes we have here. Where are we going to use UAS, and where are we going to use the infrared thermal imaging? Types of different equipment. We'll touch base on regulations. And as Matt related to earlier, we'll have a question and answer session midway through, which is new, and then one at the end also for your questions. When we talk about applications, we have literally, I would say, at least 100 applications. We're going to just touch base on a few of them today. It seems like every week and every time I do a SUAS course, by the way, I have one next week in Nashville, we learn of a new application: roofing, property inspections, building diagnostics, agricultural, search and rescue, fire, utility, solar panels, and that's just to name a few. I just got back from the International Roofing Exposition, as we were talking about earlier, and there was a huge interest in the application of SUAS and thermal imaging for flat roof membranes. And the image you see here is a visual one taken during the day. You can see the shadows off of the HVAC units. And on the one on the right, you can see the moisture underneath the membrane. The advantages, the roof inspections, the huge advantage is you can cover a lot of square footage of area in a short period of time. So, of course, we have to be a good pilot in order to do that, but you see the image today in front of you is a fairly good image of not having to fly too high over the top of the roof and still get great infrared images. Another application that has really become popular is agriculture and livestock, tracking livestock, taking images of livestock, horses, cattle, and just checking their conditions. Here you'll see an image from the agricultural standpoint, and had a lot of inquiries here as well, as from everything from cranberry farmers to other farmers and agricultural folks just wanting to know, do I have too much pesticide? Am I overwatering the land? And this can be determined with infrared thermal imaging as well. Solar panels has been a very, very good application. And so we've seen a lot of interest. Almost every course I do, there's 2 or 3 people that are from the photovoltaic industry and are using infrared thermal imaging on SUAS.
Hey, Bill, don't want to cut you off. I apologize for the interruption. A couple people are saying we're having trouble with the video coming in. The main webcam that says ITC USA has been paused, and that's intentional. That's my webcam. I'm not displaying my webcam right now, so I don't upstage Bill while I'm answering questions. But you should see the PowerPoints listed on the screen as well. The PowerPoints are the bigger slide. I'm seeing them right now. I think everyone else, send us a quick question. If you're not seeing the main PowerPoint, Bill's got a PowerPoint slide up there right now. It says aerial imaging, perform visual and thermal. Looks like most of you can see that PowerPoint slide. Okay, so we are broadcasting. If you just see the pause screen, for some reason that PowerPoint is not displaying, and I'm not sure if it's an issue with the software, but most can see it fine. So it sounds like these are localized issues with the respective individuals that are having that issue. Try on the view option on the upper right-hand corner, try to reset the view settings there, but it looks like we are seeing the slides. So we're good to go, Bill. Sorry for that interruption, but you can go ahead.
Oh, no worries, Matt. Again, solar panels has just been a huge application, easy to access on flat roofs. In order to get the optimum results, though, we have to understand that there are some challenges. What degree is the solar photovoltaic system installed at? Is it a 45 degree, a 60 degree? And of course, if we fly this with an infrared camera, angle is of great importance when we use infrared thermal imaging. If the angle is too excessive, we get more reflection. So we have to compensate when we do solar panels to make sure that our angle is correct and we get a great image. Here's another great image. Of course, we know that a cell that is working improperly is going to retain the energy, hold the energy. So it's going to overheat. So here in these two images, you'll see examples of solar panel cells that are overheating. Here's another image of the previous image of a PV array that shows solar panel cells overheating again. Of course, if we get the wrong angle, we could get a reflection that could make this happen. Of course, the other things that could make it happen is dirt and debris. Bird doo-doo on the photovoltaic panels can make this happen also. So as we fly and as we look at the infrared image interpretation in all applications is, of course, very important. Here's a great image from the air about emissivity on electrical components. Of course, emissivity is the ability of any material to absorb and emit infrared radiation. And what we see here in the center of the screen is the top connection with the harness. And of course, this is not energized, but it's still generating heat. It's called mechanical stress. So the camera did a great job here of identifying the darker colors that you see on the wiring is because it's probably aluminum. Of course, aluminum reflects and does not emit. Another real recent, the last 4 months, I've had a lot of phone calls on using small unmanned aerial vehicles for optical gas imaging to detect gas leakages. And I'll be doing a conference for the 4C conference in April on just this topic. But this has, again, been a very sought after application. Of course, this takes a different camera. This takes a camera called the G300A gas detection camera. And as far as I'm concerned, the experts in putting this together on the right platform would be Viper Drones. And we'll see some information on their company later in this presentation. Here's a typical image you might see from the G300A. It's a great overall video. It is not one of a gas leak. However, it does take amazing images, and there are some challenges here, in that we may have to make sure that this is installed properly and it's installed on the right platform. Another nice image here of overhead power lines. Advantage is, again, we can fly a lot of power lines and we can get closer at much less cost than a helicopter or a plane. We'll talk a little bit here about different types of cameras. The FLIR Duo is a 160 by 120 resolution camera. We'll talk a little bit more about resolution coming up in the presentation. It's a long wave camera. So it has the opportunity to give you both visual and infrared images off the same camera. Again, this has to be installed on the right platform. It can't be on a gimbal system. So you have to get with the right technician to have this installed also. The FLIR Dual R, again, this is radiometric camera. And we'll speak a little bit about the difference between radiometric and non-radiometric. So as we go through, the new camera that's out is the FLIR Duo Pro R. A lot of benefits here: higher resolution, able to capture video and still imaging in both thermal and video simultaneously, which is just amazing. And so we've had a lot of calls for a camera like this that's both visual and infrared, and we now have it out there, the FLIR Duo Pro R. Just a quick screen on the Duo Pro R. Two different resolutions, 640 by 512 or 336 by 256. It's a 30 hertz. Of course, hertz means the number of times that the image is repainted or refreshed per second. So 30 times a second, we're going to replace that image or repaint that image. Really important. It's important to know accuracy too. Down at the bottom, you'll see plus or minus 5C or 5% of the readings in the different ranges. The FLIR View Pro specs are here for you as well. Again, two different resolutions. And each of these cameras have three different lens options. So it's important to analyze your application or your potential applications and choose the right resolution with the right lens for that application. We'll look at the ZenMuse XT gimbal. We can see that that's available also in two different resolutions, 336 by 256, 640 by 512. I've been getting quite a few questions also about the XT performance line or the XT radiometric line. And questions are referring to, what is the difference? They both measure. Well, the difference between the two is the XT performance line will only allow you to measure a spot radiometer. So you'll have one measurement spot. The radiometric version means that each pixel contains temperature. This allows us to use a measurement box tool to give us average, highest temperature, or lowest temperature. And the reason behind this, because the pixels actually measure the temperature of the image in radiometrically. So what that means is that you get less margin of error with the radiometric camera, and you get a larger amount of measurement tools with the radiometric camera versus the XT professional version, which just gives you a spot tool and about a 14-degree, can be a 14-degree margin of error in measurement. So that's huge. But some options here again. We'll take a look at these different options, 640 by 512, and there's several different lenses. We'll talk about lenses here in just a few minutes as well. You need to let the camera warm up, just like a handheld camera. We have to have a thermal gradient. No delta T, hey, no thermography. We need to have that difference in temperature. There are spot size ratio considerations, and some of them are huge because we're going to be from the air, 50 feet, 150 feet, 200 feet. We can image from multiple angles, and we can get a lot of reflections from other objects. So I'll let Matt jump in here.
Excellent, Bill. We'll take some questions here in a moment. I've got several that just came in. But first, I just want to say just briefly about Information 2018. It's coming up. It's the world's largest IR training experience and networking event for infrared thermographers. Whether you're a beginner or a seasoned pro, Information is your chance to improve your knowledge and proficiency in thermal imaging and its various applications and techniques. We're going to be in Austin, Texas this coming September 11th to the 14th. You can head to information.org to learn more and register today. And I should add, by the way, today is the final day that we're offering the early bird special rate where you can save up to $800 off of the VIP package. That's $800 US. It's a great deal. It includes a FLIR E8, a number of other items. Again, it's information.org, and we hope to see you guys there. All right, Bill, we had some questions that came in during this question break and earlier. I know you're going to talk about lenses here in a moment, so I might hold off on that. But I think this was a recurring one. I guess, well, we'll hold off on that because interchangeable lenses, I guess, came up. I don't know if you're going to address that here in a moment, but let me ask it then. Are there interchangeable lenses available for the SUAS applications? Is that something that's an option for people that are going to use aerial infrared?
Hey, we could, at this point in time, we cannot change lenses on our SUAS infrared cameras. And the reason behind that is whenever we change lens, we also have to let the camera know what's happening with that lens. So the camera knows the field of view. Unfortunately, that can't happen right now with a SUAS camera.
Great. Thank you, Bill. Thanks for the question, the answer there. Let's see. I guess another question that came up with specific to optical gas imaging. What type of equipment is being utilized for that at the moment, and what kind of platform? A person was asking about the workflow for all of that.
Sure, that's it can be very quite complex. The GA300 camera is going to require, number one, more power. Number two, a larger platform. And I'm not the expert in platforms by any means. So my recommendation would be to contact www.viperdrones.com. They have the answers, and I've referred quite a few people to them, and the people I've referred have appreciated the referral. So I would contact those questions.
You said
might help.
viperdrones.com?
That's correct.
I'll put that on the chat window there for people if they want to click on that. Viperdrones.com. I sent that out there. Let's see. Another question. We'll take this one here. Best way to span and level with the FLIR XT radiometric series camera. I guess what are people's options with that for adjusting span and level?
Well, in your controller, you're going to have several options. And those options allow you to eliminate background, increase background. The best option, as far as I'm concerned, for still images, for static images, is to get the best focus we can get and do thermal tuning in FLIR tools. And we're going to talk about FLIR tools later in this presentation as well.
Okay. Let's see. I think that's good for now. There's a couple of questions I might take offline, but you know what? Let's continue forward. If there's maybe I don't know if the mic is falling down or something. We're getting a little bit of the cutout on the audio there, but we'll come back to some other questions here in a bit, Bill. But we'll move on.
Great. Hey, let's talk about resolution. Hopefully this sounds good for everyone. And again, very excited here. We've got about 360 people at this tutorial right now, so very excited. Resolution. Hey, we take a target, and when we take that target, we may have the target at different distances. So when we take that target, we need to put pixels on that target. Remember, pixels are very important. Resolution is very important with a visual camera, but with an infrared camera, the pixels also record temperature data. So it's very important to have as many pixels as we can on the target. So we take the target and we put pixels on it. The more pixels, the better the resolution, the better the image, and the better the temperature measurement if we need to measure temperature. We take a roof. If we take a roof from, say, 100 feet up or 75 feet up and we put pixels on it, the question is, are we capturing all the anomalies? And the answer is, of course not. It's impossible to capture all of them, but our objective is capture as many as we can so that we can get the best data we can for ourselves and for our clients. Talk a little bit about instantaneous field of view and measurement field of view. We talk about milliradians. A milliradian is basically like a slice of the pie, if you want. Portion of a circle. And the smaller the milliradian, the more telephoto our lens will be. And we'll jump into lenses here a little bit. But 1.308 milliradians would be a narrower field of view. In other words, the area that I'm able to measure or see is narrower, but more telephoto. 2.519 might be a wider field of view, so I get to see a bigger area. So for roofing, for example, I would want a larger field of view. That means less passes over the roof. For electrical, because I don't want to get very close to this because of electromagnetic interference, I might want a telephoto. So we'll talk about that a little bit more as we come up. So we have to talk about measurement, field of view, and spots, because it's totally different with an SUAS infrared camera. How is it totally different? Well, let's take a look. If we have a 640 by 512 Zenviews with a 13 millimeter lens on it, our spot size in inches is about 4.7088 from 300 feet. Now, I know not everybody's going to be up at 300 feet. This is just an example. But we now know that the pixel size for measurement from an SUAS infrared camera is 5 pixels. So if I look at that, my measurement of area from 5 pixels at 300 feet is 23.5 square inches. That's a pretty huge area compared to handheld. And if I use the same example on the right on the 6.8 millimeter, I'm going to have a 45 square inch measurement area that I must capture in order for me to measure accurately. So just some examples here for you. Again, emissivity of the surface plays a huge difference. Of course, emissivity, again, ability of any target to absorb and emit infrared radiation. Here in this example, you see a roof that has some poor roofing material or damaged roofing material, loss of the granules, loss of the roofing material. The emissivity has changed, and therefore it looks different, and it may not be moisture, it may be just the roofing material. Angle of view is very important too, as you can see in this image. You're just looking at a building. If you look at the very top, you're going to see differences in temperatures. So does angle change our temperature? The answer is absolutely. It also changes what we see. At the very top of the windows, you might be looking at the sky. It may be reflecting the sky. In the middle image, you might get a portion of the sky, and at the very bottom window, the bottom AR1 square, you're probably looking at the ground or the trees. So angle of view is very important. This is what your camera sees, so you need to know what your camera is actually seeing. Angle of view on a roof is absolutely important. Handheld, we say that we should not look at a roof with any angle less than 60 degrees to target. As we get to 60 degrees and lower, reflections increase, emissivity decreases. So we get reflections like the image on your left and your right. Here's a great image, emissivity from the air. If we look at this image, we see the tanker truck, and of course it's probably a stainless tanker truck, but if we look at this image, you see some interesting things. The top of the tanker truck is dark purple or blue, and that's directly reflecting the sky. The bottom of the tanker truck is yellow in color. That's directly reflecting the ground and the energy that the ground's giving up from solar load. So this is what you can expect to see from highly reflective items from the air. So viewing angle is just very important in SUAS. Solar panels, flat roofs, almost everything we look at, including oil and gas, that viewing angle is of great importance. So we have to search for that proper viewing angle to get the right angle. Again, roofing, it's all about time savings, whether it's on the roof, flying power lines, looking at agricultural, we get a different view from the air, a view that maybe other people can't get, including airplanes or helicopters, and a view that saves us a lot of time and money. Hardware. Of course, we have the different types of hardware. We have the DJI controllers. There's other controllers out there that perform differently. And we also have different types of software out there. The DJI Go software and the XT software now allows us a lot of interaction. We can actually do things like nuke the camera. And if you haven't heard of nuking, nuking is very important because it refreshes the pixels on your camera. We discuss this a lot in the level 1 SUAS course and show you how to do that in this course as well. So nuking is very important, non-uniform correction. If you're looking for something that's just ready to fly, you're not the type of person that's going to have it built. DJI has the packages where you can just purchase everything in one package. Of course, this doesn't fit every application and it doesn't fit every need. So we really need to understand our application, understand where we're going to fly, and understand our mission before we get started in the purchase process. And with that, I have a lot of people that come to our courses that say, hey, Bill, I haven't bought a camera, I haven't bought a platform. Is it still okay to come to the class? And my answer is absolutely. Hey, I think it's fantastic that you're coming to the class to learn what your applications may be, and then tailor design that camera and that platform to your application. It's all about return on investment. So I appreciate that. Remember, with these cameras, you're going to get about an 18 to 20-minute flight time, and that depends on temperature too. So make sure you know the temperature. I recently flew into 15-degree weather, and I got about 8 minutes out of the camera. Or I'm sorry, out of the battery. So be aware of flight time. Here we're talking a little bit about regulation, and of course, we are not the experts in regulation. There are a lot of great trainers out there that do a wonderful job with regulation, but we want to make you aware of it anyway. There's certain things we do cover in our course with FAA Part 107, and that's just to make sure you're aware of the safety. Some basics here. It's just less than 55 pounds, no faster than 87 knots. Of course, we know the altitude is 400-foot AGL, and there's other standards like waivers. Which waivers, what's the difference between a waiver and an authorization? And we won't get into all of that here. But it's important to know that if your application is looking at roofs, you may need a daytime waiver that will allow you to fly that roof after hours to get optimum results. So again, it's all about planning. We're in a huge market here. If you're just new to this, or even if you've been involved in it, the numbers are just astounding. We're talking about 13.8 billion in growth over the next 5 years. And I think it's a little bit larger than 500 million currently, but you're going to see there's a huge amount of growth opportunities here. ZenMuse and FLIRView, you can just see what's in the box here on the screen. And of course, these are going to be gimbal systems. So they can be just core systems. It depends on how you wish to apply it to your platform. Some people prefer to put together their own or have one custom built. I think this is good as well. If you understand and know your application, like optical gas imaging, you surely wouldn't want to buy one out of the box. You want this custom built. And there are several different companies, which we'll talk about in a few minutes here, that can help you custom build it. And I would call them the pros in the industry. However, if you're just getting started, you want to fly flat roofs, out of the box works great. So it depends on you, depends on your application, your objective, and your mission. Here's the companies I was referring to earlier. UAS Thermals is located in Florida. Todd Hillhouse, I can't speak highly enough of him, a true professional, and their crews there can take any application that you have from agricultural right on down the road. The one on your right, upper right-hand corner is RMUS, Rocky Mountain Unmanned Systems in Salt Lake City, Utah, I believe. And they also are what I would call true professionals. And they understand your application, they interview you, find out what questions you have, and go from there. We spoke earlier of Viper drones, a quick introduction to them down at the bottom of the screen. But again, Viper drones, these are all FLIR distributors. They're all great people. So questions as far as which camera for which application, what's my platform need to be for my application for the camera I wish to purchase, they will answer all those questions for you. And they're, again, true professionals. We'll talk a little bit about FLIR tools. Okay, I'm up in the air. I've taken the image, or I've taken multiple still shot images. And how do I get them on paper? Of course, it's great that we can take the image, but how we deliver our report, how we deliver information determines how professional we are as well. So how are we going to get that information to the client? Or how are we going to capture that information and keep it? There's two versions of FLIR Tools. There's FLIR Tools, and it's free. And you see the website down at the very bottom of the page. If you go to that website, you can download the free version. And again, this is free. There's no strings attached. You can take the image, process the image in FLIR Tools. The second version is FLIR Tools Plus. FLIR Tools Plus has added features meaning more color palettes, more measurement tools. The biggest feature that I think FLIR Tools Plus offers, which is an amazing feature, is called Panorama. And we'll look at an image of Panorama here in just a few minutes. But Panorama allows us to take multiple still images and stitch them together in one image radiometrically. So this is a huge advantage when we're from the air. And I've had a lot of questions about, can I process my video in FLIR Tools? And the answer is no, you cannot. It only processes still images. The video images are 14-bit and cannot be processed. So you cannot process the video in FLIR Tools. Yes, you can play it, but you cannot process it. The other thing one can do, that I would think that's probably one of the most unused features, a lot of the systems will allow you to do program sequence mode. So I can take multiple images at one time. And those may look like a video if I put them in on 10-second increments. And those are all individual still images that I can now process in FLIR Tools. A lot of options here. If I take the image and I double click on it, that gives me the opportunity to view all the object parameters. Take a look at the very bottom. You'll see the auto menu down at the very bottom allows me to thermally tune the image in FLIR Tools. Here I can adjust level and span and adjust contrast and brightness to bring out the finest details in the thermal image. And this is very important when you're taking a look at thermal images. I can change color palettes. And the thing I like about it is I just click on it and I just move my cursor over the different color palette, automatically changes it for me to choose which palette works best in my image. And of course, different color palettes will work different for different applications. I can select measurement tools, and you'll see these measurement tools off to your left, upper left-hand corner. But I would really suggest that you just download the free version and take an infrared image, or there's infrared images online. Just take an infrared image and analyze it. It's really important. I would like to thank everybody for joining us today. Again, well over 350 attendees, and I'm very grateful for that. So again, my contact information is right here, william.schwan@flir.com. And if I can ever help anyone, or if you ever have any questions after the webinar, feel free to just drop me an email and I'll get back to you as quick as I can. And I think we want to open it up for questions now, don't we, Matt?
We do, Bill. Thanks. Let's see. We had a bunch of questions come in. Mike had asked earlier, and Bill, maybe this is like a three-part question. What setup would you recommend for, let's say, for buildings, roofs, and electrical? That's a pretty big question there, but I think people who are getting into this want to know what maybe they want to consider for those specific application areas. Is there maybe something in general that you could maybe help them out with, a tip in terms of what they're going to be looking for? You know, resolution, equipment type, and all that?
Hey, Mike, I really appreciate your question. When we purchase a SUS camera, of course, we don't want it for one application. We're making a huge investment here. So what we want to do, you mentioned roofing, electrical, is here's my opinion. My opinion is I'm a real fan of the ZenMuse XT radiometric version. And the reason for this is the resolution. The resolution is huge. This is a very stable camera on the gimbal. And the other lens that I would recommend would be 13 millimeter for that application. It's not real wide angle. The 13 millimeter is between, of course, 9 and 19. We have 19, 13, and 9. So I would recommend the 13 because you're getting the kind of a mid-range as far as the lens application. And then the Inspire 1 works great for that. In my opinion, that's what I've flown in those 3 applications, and it works great. Hopefully that helps you to answer your question.
Good. Okay, Thomas was asking earlier about what drones is the Duo Pro R compatible with?
The Duo Pro R is going to be more of a matrice. If we're looking at a DJI product, it would be a matrice platform, in my opinion. And there may be other opinions out there, but that's why I would recommend you to SUAS Thermals. They answer your question at no fee, or RMUS or Viper Drones at vipers-drones.com. I got that one right this time. So that would be my recommendation, is contact them, because there's also power requirements.
We had a couple questions come in about PV arrays and PV sites. First was inspection frequency, and the other one that just seemed to come in here, Bill, was maybe equipment type or resolution. But first, inspection frequency that was asked about for PV sites.
It just varies. And the reason I'm saying that is it varies by age. Of course, one that's a little bit older, it might be something you want to do every quarter. Of course, there'll be other ways of measuring productivity. It isn't going to be from the air. This can also be measured by devices that are attached to the unit. But what we're seeing is about once a quarter, depending on age. If they're newer, once every 6 months. So that's what I'm seeing from people that attend our course.
Okay. Maybe you can speak briefly for a moment about radiometric versus non-radiometric solutions for aerial inspections. When would you use one versus the other? For someone getting into this, why would they care about either one?
Absolutely, non-radiometric. I'm going to fly the roof, and I'm going to do what's called a qualitative inspection. So flying a roof membrane to look for thermal patterns of where moisture might be, where structural, or where nailings are, is qualitative. So we might not need or require a radiometric camera for that version. However, we might be flying electrical and I see something that's hot. Well, of course, how hot is hot? If it gets too hot, we'll get to the correction point or the melting point of the component. So is it 300 degrees hot, or is it 900 degrees hot? In an overhead electrical, that can happen. So at that point, we'd want something where we would be radiometric. We'd measure it. So just some examples of different applications in radiometric and non-radiometric.
And Bill, a couple questions just came in again. I think people had missed the answer there. In what capacity is FLIR Tools compatible with any of these platforms for processing images?
FLIR Tools is compatible with all of the cameras as long as they are static images. In other words, still shots. It will not allow you to produce, it will allow you to produce and watch the video. It just won't allow you to do box tools, measurement tools, and actually work inside the image. So also keep in mind that many of these platforms also have what's called TIFF images. Of course, TIFF images are important, but you can't process them in FLIR Tools. So what can we process? We can process still images, radiometric, in FLIR Tools.
Some questions coming in, Bill, about training requirements for a clearance for flying, not necessarily thermography certification, but more so for being a pilot. I guess if you could briefly chat about that, what do people have to consider if they want to be qualified to fly?
If you're going to qualify to fly, I would recommend that you would look at FAA.gov/UAV, Unmanned Aerial Vehicles, or UAS, I'm sorry, Unmanned Aerial Systems.
You run that back and type it in, Bill. What's the website again?
It should be www.faa.gov/ I believe it's UAV.
UAV. I'll put that in the chat window there. That's all. Thanks. Okay.
And go to that. It's going to give you all the different requirements. It gives you a study guide, and you'll need to know things like airspace, how to properly read a chart, weather, how to interpret weather, weighting factors. There's a lot that goes into this, and most people are offering a 3 to 5 day course as a prerequisite.
Kurt was asking about angle of view, and you had mentioned 60 degrees, and what's that all about with aerial inspections?
Absolutely. So if I'm flying through the air and my camera is pointed straight down, that's considered 90 degrees. That's going to allow the radiation to best be interpreted by the camera. If I'm flying at an angle to that target, or I am away and I'm less than 60 degrees or parallel to that target, the camera does not have the capability of capturing the radiation because I'm seeing more reflected value from other targets than actual emissivity emitted from the target. So angle is very important in SUAS, sometimes greatly overlooked.
Let's see here. We had a lot of questions come in. We'll take a few more, but if we don't happen to get to your question today, I've got Bill's address up here on the slide. My email address is here as well. We will save the Q&A, and I'll probably browse through it here at the end to see if we missed anything that's critical. But if you really want an answer here and we don't get to you, just jot down our email address here, and we'll get right back to you there over email. There's a lot of questions coming in, so it's hard to sort of sift through all of these, but we want to try to get to everybody's answer here. Unfortunately, we're not going to get to everyone who's on right now, but if you want to email us, we can certainly contact you personally at the end of the event. Let's see here. I guess any of these solutions that we're talking about would work for search and rescue. Is that right, Bill?
Yes, search and rescue would work great as well because we're not so concerned about measurement. We're concerned about qualitative. Can we find the lost individual or the lost animal? Can we locate that image based on, or that target based on detection, recognition, and identification? So the greater the pixels, the larger our chance of actually finding that individual. And of course, we're not concerned about measurement, search and rescue. So, my recommendation is, you can use any camera you wish, but a non-radiometric camera with great resolution is going to help you sort through and find your answers.
Question just came in again. Yes, we are recording the session, so we'll have these video here and the questions that you're getting right now available for playback at a later date. Within the next week or so, we'll get those up on our website, and then if you've registered, and obviously if you're here, we'll be sending out a reminder email when that particular video is ready to go. We've just got a few more, Bill, that came in. We might take some of these offline here. There's a lot of great questions, but unfortunately, I just don't think we're going to have the time to get to everyone's here today. Maybe speak about, back to the applications here for a moment. If you're doing roofs or aerial for utilities or whatnot, what are some considerations for the conditions, time of day, things like that for inspecting with aerial infrared?
Oh, this is a great question. Of course, depending on the application, for roofing, for example, we have to allow the moisture underneath the membrane to absorb all the solar load and heat up. Of course, then we have to wait for the solar load to leave. So you might be flying a roofing application after dark. Of course, overhead electrical. Hey, here we better make sure our wind speed is minimal. Last thing we want is a blow against or a movement, push against any wire electrical conditions. So the other thing to be concerned with is EMI, electromagnetic interference. Will that affect our vessel, affect us to control the vessel? All those things have to be, or should be, pre-planned before the mission. So it's very important that the conditions are proper. When did I last water the field? In agricultural, that's very important because that's going to determine whether or not we can see the watering conditions in that agricultural application. So knowing and understanding your application is first and foremost to getting great results.
So we had a correction there on the website, by the way, and I'll put that up there in the chat window. Thank you, Rosa, and whoever else had mentioned that. It's faa.gov/UAS. I think we need to settle on one acronym, folks. There's three at least, and SUAS, UAS, or UAV. We need a standard on that, perhaps. So thank you for the correction there. Let's see. The electromagnetic question came up earlier, and I apologize if I misled someone on the answer there. But how much of an issue is EM interference, perhaps, if you're in an urban environment? That was the question a viewer was asking a little while ago.
It's very important. Of course, we know that we're operating in 2.4 to 5.8 gigahertz. What's that? What else operates in that waveband length? Well, quite simply, your cell phone. So you now can purchase devices that will tell you what your EMI is at your location. Of course, that's not what it's going to be AGL, but it's going to give you a better idea than not knowing at all. And of course, once we lose connection, it's very important to regain it. But it's very difficult to regain it, or it can be difficult. So in urban areas, if you're flying between buildings, you may lose it just because of the EMI from building to building, especially if there's microwaves on top of those buildings. You may lose it just because you briefly lost line of sight, but you lost connection with that unit. So knowing again where you're at, understanding EMI is very important to you controlling the vessel. And of course, the last thing we want to do is have an incident. So this is very important.
So speaking of incidences and such and regulations, question came in about permission to fly in urban environments, and the gentleman was asking about the Washington, D.C. area. I know it's very difficult for even commercial or private aircraft to operate in that area. Is there, I guess, a resource where people can go to look at for that? I guess, that's the question that's coming up there is, how difficult if you're going to be, doing work, let's say, in the district, what do you need for approval, or is it even possible? Things like that.
In the Washington, D.C. district, I've had several students from in our SUS classes, and they're telling me it's nearly impossible to get a waiver to fly in that area. It's just probably not going to happen. So just keep that in mind. If you do get a waiver, you're going to spend 6 months to 9 months getting it, because they're going to interview everybody associated. And I know that because I just applied for a waiver that Matt and received it for our Nashua Training Center. So the answer is probably nearly impossible in the DC area.
Katie had written in, there's an app before you fly, which I'll chat out there. It's B4U is the letter fly, as an app that you can check out as well. Thank you, Katie, for that suggestion. And there's also information on the FAA website as well. All right. Bill, I think we're going to wrap it up on that. We've got a lot of great questions. There's more questions that came in, but I think we'll take these personally via email. If you want to send us this question, either to myself or Bill, we'll get you the answer there because there's just a variety of different questions that are coming in, and we'll get back to you as soon as we can. Like I said, we're going to have the recording of this available, and we'll have that up within the next week or so. So you can check out our website if you go to infraredtraining.com/webinars, and let me pull that up there. It's infraredtraining.com/webinars. I'll back that up. Oops, there it is. That's where you can get all of our on-demand topics that are available for free for viewing anytime. We've got more live dates and times also listed there as well. And in fact, we'll be back here at 2 o'clock this afternoon with John Wagoner on an overview of NFPA 70E, the basics of electrical safety. So that's coming up here in a couple of hours as well. And like I said, with the recording, we'll get that up there. And if you want to learn more about other training dates, or I should say tutorial dates or whatnot, we're very active on social media. You can join us on Twitter, Facebook, YouTube, LinkedIn, or Instagram, where you'll be notified of upcoming dates and, of course, other training events and whatnot. Before we wrap, Bill, anything you want to say just in conclusion here before we go for today?
The only thing I want to say is thank you. Thank you. This is the largest number of attendees, Matt, that I think we've ever had. The only other thing is I know just by the number of questions that I'm going to get a lot of them. So if I don't get back to you immediately, I'll take them first one in and answer them in order. But it may be into next week before I get back to you. And of course, I'll be in Nashville delivering the SUAS Small Unmanned Aerial Systems, Matt, by the way,
nice
course.
Nice.
Thank you, everyone, for attending.
Well, we got Bill's address there, william.schwan@fleer.com. Send him an email, or if you can't get through to Bill, email me, We'll get you an answer. We'll work together, get the information that you need. Thank you for all your questions today, and thank you for your participation. Again, we've recorded this, so it'll be available online here in the coming week or so. And hopefully we were able to at least give you an overview or some of the basics of using infrared with an aerial platform. All right, until next time, for Bill Schwan, I'm Matt Schwegler with the Infrared Training Center. Thanks for joining us today, and we'll see you online again soon for a future live tutorial event. Take care.